Welcome to the video for SmartTut 4. In this week's video, I will be covering the actual problems from the TUT with you, since you do have a project tutorial this coming week. We are looking at the procedure exercises, and it says determine the function u if du dt equals 1 plus t to the 4 over ut squared plus u to the 4 t squared. Alright, so the first thing we want to see is whether we can separate our variables. In other words, whether we are able to take all of the one variable, so all of the u's together with the du to one side of the equation, and all of the other variable, in other words the t, together with the dt to the other side. So we are actually able to do that in this case. So let's just write our differential equation as du dt equals, and then 1 plus t to the 4. Then I'm going to take out a common factor of t squared in my denominator. And then I'm left with u plus u to the 4. Now I'm going to separate my variables. So I'm going to take all of my u's to the left hand side and all of my t's to the right hand side. So then I have u plus u to the 4 du equals 1 plus t to the 4 over t squared dt. My next step is going to be to integrate on both sides. On the right, I'm just going to split it up into two integrals so that I have the integral of t to the minus 2 dt and plus the integral of t squared dt. Then I'm going to integrate on both sides. So on the left hand side, I'm going to have u squared over 2 plus u to the 5 over 5 equals, on the left hand side, I'm going to have minus t to the minus 1 plus t cubed over 3 plus c. I'm just going to write that as 1 over t. And in this case, we cannot explicitly solve for u, so we leave it just like this. Problem number 2 says solve the differential equation dh dr equals r multiplied by h squared multiplied by the square root of 1 plus r squared over ln of h. So once again, can we put all of our h's on one side and all of the r's on the other? Yes, we are once again able to do that. So this is a separable differential equation, and we can solve it by the separation of our variables. So what I'm going to do is I'm going to take all of my h's to the left hand side and all of my r's to the right hand side. So then I have ln of h over h squared dh equals, and then I have r multiplied by the square root of 1 plus r squared dr on the right. So I integrate on both sides. So let's just look at how we're going to solve these two integrals. I'm going to do the one on the right first. So remember, whenever you solve integrals, the first thing you look at is, do you immediately just know the answer by looking at it? If you don't, then you check, can I use u substitution? For u substitution, u will usually be the inside of something, not always, but usually, and the derivative of what you said equal to has to be inside of your integral as well. Only the variables, you can disregard constants. So in this case, if we were to say u equal to 1 plus r squared, then du equals 2 r dr. So that means that du over 2r equals dr. So this integral is going to become the integral of r multiplied by the square root of 1 plus r squared, which is just the square root of u, or u to a half, du over 2r. That r and that r cancels. So we have a half, and then we have the integral of u to a half, which is u to the 3 over 2 over 3 over 2. Right, so this is just, and don't forget your plus c, sorry. And this is just going to be a half times 2 over 3 times u to the 3 over 2 plus c. So this is just going to become a third, and then we have the square root of u cubed plus c. On the right hand side, what I'm going to do is I also want to solve this integral by going through my steps. So the first thing I'm going to do is I'm going to see whether I immediately know the answer to this integral. I don't. I definitely don't. Also, substitution is not going to work, because if I were either to set u equal to, let's first say ln of h, then the derivative of that is going to be 1 over h, but we don't have a 1 over h in our integral. Also, if we were to set it equal to h squared, then the derivative of that will be 2h, but we don't have that inside of our integral. So the next thing we can check is it perhaps a product of two functions where we can use integration by parts? And indeed it is. So what I'm going to do is I'm going to, for my second integral, I'm going to do integration by parts, and I'm going to set u equal to something, and I'm going to set v equal to something. So usually if you do two substitutions in one problem, like I did here, it's better if you were to make this variable another variable, for instance a w, just so that you prevent confusion. But I've already done it with the u, and I don't want to do integration by parts with other variables because I don't want to confuse anyone with the formula we have for integration by parts. But just remember, it's better to use a different variable. Alright, so when I set u equal to something, I want to set it equal to something so that the derivative of u becomes something that's a little bit easier or simpler or better. And I also want to make sure that what is left, which will be the integral of everything that's left, dh, which is equal to v, is an integral that I'm able to do. So if I set u equal to ln of h, then I have that du equals 1 over h dh. V is then everything else that remains. So it's the integral of h to the minus 2 dh. So it means that it's going to be minus h to the minus 1. So let's see if that will work. So I'm going to take u multiplied by v. U is ln of h. And v is minus h to the minus 1, or minus 1 over h. So I have minus ln of h over h, minus the integral of v, which is minus 1 over h, du, which is 1 over h dh. So this just becomes minus ln h over h. Then I have plus the integral of 1 over h squared dh, and 1 over h squared is just h to the minus 2. So I have minus ln of h over h minus 1 over h plus c. Right. So on the left hand side here I have minus, I'm just going to change that to a c1. I have minus ln of h over h minus 1 over h, and I'm not going to write a constant here as well because I integrated on both sides. So on both sides I obtained a constant, but you might just as well write only one constant. So since a constant plus a constant is still a constant. So this is what I get, and once again I'm not able to solve for h explicitly, so I can just end here.